Hello guys. So now we're going to look at graphical methods in solving in solving problems that involves motion of particles, right? So when we started learning about equations of motion, I mentioned that there are two methods that are available. We can use either equations of motion to solve problems that involve motion, or we can use graphical methods. So this is the beginning of graphical methods. So when it comes to graphical methods, you learn about displacement time graph, velocity time graph, and acceleration time graphs. So you have learned these things in physics, right? So each graph has its own advantages and disadvantages, but in combined mathematics, in applied mathematics, we will only focus on VT diagrams, right? Mostly VT diagrams. So your paper will consist of a question that requires you to draw a VT diagram, right? More than 90% of the time, 99.9% of the time, you will be asked to draw a VT diagram. But you should also know about ST diagrams and AT diagrams. Right. So since you learned about displacement time graphs, that means ST graph, we will not focus on that. We will only focus on VT graph, and with time, if we have time, we will. I will show you how to draw AT graphs as well. But keep in mind, AT graphs will not be present in your question paper. That's a highly good chance that it will not be there in your paper. Right. So let's start with VT graph. So what is the definition of a VT graph? What we can obtain from a VT graph. So velocity time graph, in short, we say VT graph. It graph shows speed and direction an object travels over a specific period of time. So you can see that speed and direction, right? Speed and direction and object travels over a specific time period. So speed and direction. What gives you speed and direction? Both speed and direction. Velocity will give you both speed and direction of a particle. So basically, this is about velocity, even though it says speed and direction. This is just for illustration purposes, because in reality, we will only see speed. We will only perceive speed and direction, not the velocity. Okay, right. So I put a diagram here just to show you how to sketch a curve in a VT diagram. So in a VT diagram, you can only plot velocity at a given time, right? So VT diagram, it's like a Cartesian plane, right? Each point in this VT plane gives you velocity of a particle at a specific time, right? Velocity of a particle at a specific time, right? So if you know the motion of a particle, if you know the velocity of a particle at a given time, then you can draw VT diagram. Right? So this is an example. This is a particle starting at t equals 0, right? So notice here above this line, above this horizontal line, velocities are positive, right? Velocities are positive. Below this line, velocities are negative, right? So you know that velocity is a vector, so it has a direction, right? So positive direction and negative direction. So we have to come up with a convention. So basically, we use the initial direction of motion to be positive, right? So if we are moving in that direction, all the velocity vector in that direction is taken to be positive. And if you reverse, right? If you turn around and come back, the direction would change. Therefore, those velocities are considered negative velocities. I will give you a note on that. So you can see that the particles start at t equals 0 with the velocity v1. So we can plot it. So I'm going to take this direction to be positive, right? Because initially it is moving in this direction. So at t equals 0 is on this vertical axis. The velocity it start with is v1, right? So this is the point v1. This point is t equals 0 v1. This is the point, right? Then imagine our velocity increases. Imagine our velocity this is say anything about it. This is just a picture. And we have V2 at T1. Suppose this is T1, right? And we have a V2. Maybe this velocity is greater or lesser, we don't know. Let's assume this is greater than V1. So at this point, this is T1 comma V1, right? You can only plot the points, right? Only plot the points in this Cartesian plane. Then at T2 times it's V3. So let's suppose at T3 times it's V3. Suppose V3 is less than V1. Sorry, this is V2 and less than V1 also. Somewhere here, T3 V3. Sorry, T2. Yeah. Then at T equals T3, velocity is 0. Velocity 0 means you should be on this line at T equals T3. Let's say it should be T2. Then at T equals T3, this is the point, right? This is T3. So let's say this point is T3, 0 velocity. Then what happens? The particle turns around. At that point, turns around and come backward, right? So starting from T0, so then it moves in this direction. Now you can see that initially we taken this direction to be positive. The initial direction of motion is this direction. So now the direction has changed, which means the direction of the velocity changed. Direction of the velocity change means it becomes negative now. So now we are on this side, below this horizontal axis. So at T equals T4, let's say this is V4, right? V4. Okay, so this point, let's take this point as T4 minus V4. Minus is because we are on the negative side now, right? Then at T equals 5, we have V5. Let's say it's increasing. Ts, suppose this is T5. So T4, T5 minus V5. Okay. Right. Good. You can see that, right? Now, if we join these points, now you don't know actually what is happening between these two locations. If you know the velocity, if you can determine the velocity at any time, that means even the time during these interval, right, between time T1 and T0, if you know the velocities, then you can plot that velocity versus time in this graph. Then what happens if you plot them? So you would see dots like this, right? Dots like this. So each dot represent velocity and time of the particle. Then what you get? If you join these dots, you get a curve. Like this, right? You get a curve. So generally, in VT graph, you get curves like this. By curves, I mean actually there will be lines, but in general you will see curves. But in your problems, the problems you will look into will consist of line segments only, right? So that is these curves are beyond your scope, but this is a general idea, right? So every curve has, I mean, if you have a curve, you know there can be slopes. The slope changes. You can see the slope changes. Slope changes here and here. Here the slope is this. Here the slope is this. Slope changes of the curve, right? Okay, so that's about it. And the slope of this VT diagram, gives you the acceleration. The slope of the VT diagram gives you the acceleration. So we will see some specific features of this diagram now. So I'm gonna put some note in the board. which would help you in dealing with VT diagrams. So we should make a note of these points. The slope of a VT diagram or VT graph represent acceleration. So you know this already from physics. The slope will represent the acceleration. So area under the curve represent displacement of an object with respect to starting point. So if you consider the area under the curve, for example, suppose you have a VT graph like this, right? VT graph like this, okay? So here this V is T. If you consider this area, from T1 to T2, this area under this curve. So curve here is this line segment, right? So the area that is enclosed by T-axis and these two vertical axes, this area represents actually the displacement from T1 to T2, right? The displacement of the particle from T1 to T2. Okay? That's what it means. Okay. Don't put this down, just keep this in mind. Then always take initial direction of motion to be positive. Any velocities opposite to this direction is taken to be negative. So this I mentioned. So you have to start some point, and at that point you are starting to move in a specific direction. Suppose you are here and you start moving in this direction, then you take this direction to be positive, right? Suppose you are dropping a particle from a height, right? So you can see, so what happens when you drop it, the particle starts to move in this direction, that is the initial direction. So you can take that direction to be positive, right? So if you are throwing a particle upward, then this direction was the initial direction of motion, that direction is to be taken positive. Now what happens if you throw a particle up, it will move upward and become zero, then turn around. Now you can see the direction has changed and come back. So in that case you should make a note that the velocity, the direction of the velocity changed, so you get negative velocity in that case, right? Keep that in mind. So when drawing VT graphs for two particles, so basically you will see these types of problems in your paper where you deal with two particles, right? Two different motions. So if you are dealing with two different motions, drawing VT graph for two particles in the same diagram, use different curves. For example, if you are having a VT diagram like this, V and T, okay, so you can use one curve to represent motion of particle A. Then you can use another curve. You can use another curve to represent motion of particle B. So this is what I meant by using two different curves for two different particles. Okay. Then time is taken to be positive. Time is always considered to be positive. So that's why in a Cartesian plane, you have y-axis and x-axis, and you have four quadrants, 1, 2, 3, 4. But in a VT diagram, you have two quadrants, V, T, right? So basically it's the first quadrant and it's the fourth quadrant. In the usual convention, this is the fourth quadrant, right? 1 and 1. That is because the time is taken always to be positive, so we don't consider about this part, right? This region of VT diagram. So that's why time is taken to be positive. So before we begin plotting curves in VT diagrams, let's look at some special cases, right? So how to draw a particle at rest in a VT diagram. How to draw a particle that is moving with uniform velocity. How to draw a curve for a particle that is moving with constant acceleration, right? So these things has to be learned, so I will get into that now. So I will get into it case by case, right? I will show you the general shape of the curve, then I will do some examples on that. Okay. Case 1 is a particle at rest. Particle at rest means particle is not moving like this, right? So you count down time You start now, you're not moving, still not moving, still not moving. So what happens? If you are not moving, your velocity is 0. And also acceleration is also 0, right? So velocity 0 means at each time, right? Each time you consider velocity is always 0. So what do you get? Starting point velocity 0. Again, if you measure the time, 0, 0, 0, 0, right? So if you join these lines, you get a curve, right? Now this curve represents a particle at rest. Notice here that you can't distinguish this curve from the time axis, but you should get the point, right? So I think the point is delivered to you. If you are at rest, and the time is running, your velocity would be 0, but the time is running. So at each time the velocity is 0. So this is what a particle at rest looks like in a VT diagram. So notice here, if your particle is at rest, it must be on the time axis, right? So if your curve cuts the time axis at some point, which means your particle at that time the velocity of the particle is 0. Right? So now we'll look at some examples of two particle problem. Right. So now you can see we have two particles P and Q at location C and D. So this is A and B. Now this is a line, right? Imagine this is a real picture. This is a real picture. You have point A and point B. At point C and D, you have P and Q, respectively. So notice here the velocity of the particle is 0 at t equals 0. Then t equals 1, same point. T equals 2, same point. That's why noted time as a column here right below the C point, because it is not moving. So similarly, if Q particle is not moving at t equals 0, t1, t2, t3, continuously in a time continuum, the particle stays at D. But the velocity of both particles are 0. So we have to take two different curves. We have to use two different curves. Let's say this represents for the particle P, right? Then we should use another color, but you know that this cannot be distinguished because we are on the time axis. මේක මම ඔයගලන්ට තේරුම් යන්න විතරයි කියන්නේ. Right? Let's say this is Q, right? So in both cases, the velocity is 0, the time is running, but the velocity is 0. So this is what it should look like, right? So now let's move on to case number 2, right? So this is a graph of a particle that is moving with constant velocity or uniform velocity. So when you are moving with uniform velocity, acceleration is 0. Uniform velocity means at every time when you measure the velocity of the particle, it's same, right? So suppose you start at t equals 1, you measure the velocity, let's say it's u. Then at t2, u, t3, u, t4, u, something. And finally, let's say this is tn time. You plot them all and you join these dots. If you join the dots using a line segment, this is the graph that shows you the particle has been in motion with uniform velocity. මේක continuum එකක් නේ. මේක හරියට එක වෙලාවක මෙහෙම ඉඳලා ඊට පස්සේ මෙතනින් මතුවෙන්නේ නැහැ. හරි? මෙහෙම යනවා. මෙහෙම යනවා particle. එතකොට දැන් මම මෙහෙම point වගේ plot කරේ අඹලන්න තේරුම් ගන්න. නමුත් මෙහෙම point වගේ අපිට plot කරගෙන යන්න බෑ. මේක continuous line එකක්. Continuous, right? ඒතර continuity එකක් තියෙන හින්දා තමයි අපි මෙහෙම line එකකින් පෙන්නන්නේ. මොකද මේක එක්සිස් මේක ක්වාන්ටම් පාටිකල් එක නෙමෙයි මේක ක්ලාසිකල් පාටිකල් එකක්. ක්වාන්ටම් පාටිකල් නම් මෙහෙම ඉඳලා වෙන තැනකින් මතුවෙන්න පුළුවන්. right? It can disappear here and appear somewhere else. එතකොට මෙතනදී ක්වාන්ටම් පාටිකල් ක්ලාසිකල් පාටිකල් එක. ඒතකොට උඹලෝ දැකලා නැහැනේ කාර් එකක් මෙහෙම එළිය තියෙද්දි මෙහෙම යද්දි එක පාට disappear වෙලා ආයි මතුවෙන විදිහට දැකලා නැහැනේ. ඒ හින්දා මේක line එකක් විදිහට පෙන්නන්න ඕන. right? So now let's look at an example that consists of two particle problem. right? So this is a two particle problem. මම two particle වලින්ම පටන් ගන්න කියලා හිතුවා. මේක එතකොට ඔක්කොම ටික එකතු වෙලා යනවා. මහ ලොකු දෙයක් නෙමෙයි. two particle කියන්නේ එක particle එක වගේම තමයි අනිත් එක. එකපාර එකයි consider කරන්න. You consider one particle at a time and you draw the graph, right? Then you consider the next particle and draw the graph. That's it. Now you can see that this is a problem. බලන්න මේ problem එකේ P and Q particles දෙක මෙහෙම ඉන්නවා. මෙතන P ඉන්නවා. Here we have at A location P particle is there and location B Q particle is there. Now they are moving towards each other. දැන් මට මේක එක line එකේ අඳින්න බැරි නිසා මම lines දෙකක් parallel lines දෙක and ඉතල බලන්න time t equals 0 වෙද්දී Q particle තියෙන්නේ මෙතන. එයාගේ direction of motion මේ පැත්තට තියෙනවා. with a velocity v, right? P particle එක ගත්තාම මේ direction එකට යන්නේ at time t equals 0 its uniform velocity is u. දැන් දෙන්නම uniform velocity එකෙන් travel කරනවා. හරිද? right. තර මම I'm going to take this direction to be positive, right? තර එක particle එකක් කොයි හරි ගන්නවා කොයි direction එක positive කියලා. q ට ගන්නත් පුළුවන් p ට ගන්නත් පුළුවන්, but initial convention you know that right hand side is taken to be positive. Right. So let's draw a curve for the p particle at time t equals 0. The u, this is u, right? At time t1 වෙලාවෙදි මෙයා මෙන්න මේ හැරි. Same u. u නේ වෙනස් වෙන්නේ නැහැ. It doesn't change. Time t2 same velocity. t3 again same velocity. Same velocity. So if you then මම මෙතනින් එහාට මේක කරන්නේ නැහැ. කෙලින්ම මට line එක අඳින්න පුළුවන්. This is u, right? So this is the path of, this is not the path, this is the curve of p curve, right? You can see t equals 0, u velocity, t1 u, t2 u, t3 u. So this is actually moving with constant velocity. So that's why we are considering case 2. Next, we look at q particle. For the q particle, you can see the direction of the velocity is different, opposite to this direction. So velocities are negative now. Velocities are negative, but is moving in this direction. Suppose now you can see that when you look at this diagram, may time interval බලන්න මෙතන t equals 0 මෙයා මේ දෙන පටන් ගන්නවා. ඊට පස්සේ එන්න මෙහෙම යන්නේ. t1 වලදී මෙයා මෙතන මෙච්චර distance එකක් ගිහිල්ලා තියෙනවා. t1 වලදී මෙයා ලොකු distance එකක් ගිහිල්ලා තියෙනවා. Which can only mean v is greater than u. හරිද? v is greater than u. v greater than u නම් මීටරේ ලොකු distance එකක් මේ පැත්තෙන් අපිට mark කරන්න වෙනවා. Right. So here it should be at t equals 0 it's v. So let's say v would be somewhere here. Let's say this would be negative v, right? Make sure to mark it as negative v. This is where you start at t equals 0. Then t equals 1, right? T equals 1, it's here. And t equals 2, same velocity. T equals 3 would be also same velocity. So if you join this line, this is only for the purpose of illustration. If you join this line, you get a straight line again. Straight line. Now this is the curve for Q. This is the VT graph or VT graph for Q. This is the VT graph for P. So we draw the curves for both particles in the same graph. The same diagram එකේ මම particle මේ graph දෙකම ඇඳලා තියෙනවා. So result this is negative. Why? Because the direction has changed. Direction එක change කරගන්න එයා negative වෙනවා. උතර මතක තියාගන්න. දැන් අපි හිතමු particle එකක් අපි උඩ දානවා කියලා මෙහෙම උඩ දාලා මෙහෙම කියලා 0 වෙලා ඊට පස්සේ උඩ හිටින්නේ නැහැනේ පල්ලෙහාට එනවා. Direction එක change වෙනවා. ඒතකොට negative පැත්තට යන්න ඕන. Negative පැත්තට යන්න ඕන. අපි ඒක ගණන් බලමු. Now we'll move on to next case. Right, this is case 3. A particle moving with constant acceleration. Constant acceleration means velocity increases. How does velocity increase? Velocity increases linearly. Constant acceleration means velocity increases linearly. So you know that v equals u plus at. v equals u plus at. So අපි graph එක අඳින්නේ v and t අතරනේ. එතකොට v equal at plus u. at plus u මේක හරියට y equal mx plus c wage, right? So we should start with the uniform velocity u. මෙතනින් පටන් ගන්නවා u, right? So with time mx plus c මෙහෙම graph එකක් අදින්න. Acceleration එක, right? If it is an acceleration, it should be a positive gradient. එතකොට මේ angle එකක් අපි දැනගන්න ඕනේ. So this is what it looks like, right? So notice here we have an acute angle. So the gradient of this line segment represent actually the acceleration. මම ඒක prove කරන්නම් ඊට පස්සේ. දැන් මට දැන් gradient of this line represent the acceleration. The gradient කියලා කියන්නේ tan theta. Tan theta is the gradient. Tan theta is the gradient and tan theta is equal to acceleration. Right. So acceleration එකක් වෙනවා නම් මෙන්න මේ වගේ line segment එකක් තියෙනවා. Right. Okay. So it should make a positive acute angle with respect to time. ඒක acceleration එකට. එතකොට angle එක increase වෙනවයි කියන්නේ acceleration එක increase වෙනවයි කියන එක. Because gradient increases means acceleration also increases. Because tan theta is a gradient is equal to acceleration. Gradient increases means acceleration increases. Gradient decreases means acceleration decreases. Then අපි බලමු example එක. Right, so let's look at an example. So the particle start at t equals 0 at a point here with the initial velocity u. So in this direction it is moving in this direction, we'll take it at positive. So it starts somewhere here. Then what happens? In this time period from t equals 0 to t1, it is moving with acceleration f. එතකොට අපි මොකක් හරි inclination එකක් ගන්නවා. effort inclination එකක් ගන්නවා. acute angle එකක්. ඊට බලමු මෙහෙම inclination එකක් ගන්නවා. It moves until this time. Okay. තර මේ point එක අපි මෙහෙම line එක ගැවුවාම we have u here. So the point of intersection will give you v1. Okay. Right. Then what happens? From t equals t1 to t equals t2, it moves with 2f. Acceleration now is 2f. එතකොට acceleration එක මෙයා f නේ. This is let's call this angle theta. මෙයා f සාමාන්‍යයෙන් අපි acceleration එක මේ line segment එක ළඟින් දානවා f කියලා. මෙතන පටන් ගත්තා මෙයා 2f. 2f means we have to have a greater inclination. Not an inclination, I mean greater angle than theta. මේ theta වලට වැඩි පොඩ්ඩක් inclination එක වෙනස් කරන්න ඕන. steep වෙන්න. ඒතරොන්න ඔහොම අපි හඳිනවා. Until this point. Okay. So මේ කැපෙන තැන තමයි intersection points is V2. Let's call this V2. Let's call this V2. Now what happens? Now the acceleration is f by 2. The acceleration is f by 2. F by 2 acceleration again then. So sorry, this cannot be equal to 0. This V3. Now here the angle, let's call it alpha. So notice here that alpha is greater than theta. Then method f by 2. F by 2 is less than 2f, also less than f. So f f by 2 less than hinda. මේ θ angle වල ටුක්ටක් inclination එක අඩු කරන්න ඕන. θ ට වැඩිය පොඩ්ඩක් අඩු කරන්න ඕන. Up until T3. So finally this is the velocity V3. Right. So notice here, so let's take this angle to be beta. So මෙතන f, මෙතන 2f, මෙතන f by 2, right? So note that beta is less than theta and alpha is greater than theta. Note. Okay. හේතුව, the reason is that මෙයාට වැඩි පොඩ්ඩක් අඩු වගේ පේනවනේ. Acceleration එක මෙතනදී starting acceleration, this is the highest acceleration achieved and this is the lowest acceleration it has achieved. කොහොම acceleration එකක් තියෙනවා නම් throughout the motion the velocity increases. කොහොම හරි velocity increase වෙනවා. Right. Case number 4 is about a particle moving with constant deceleration. Deceleration means velocity decreases. If it is a constant deceleration, velocity decreases linearly. Right? Velocity decreases linearly. So you can say the constant deceleration A is negative. Right? So V equal U plus AT. Let's say AT plus U. Right? So this is like y equal mx plus c, right? So since A is negative, gradient m is negative. Negative gradient means when the minimum inclination is negative gradient. So our line should look like this. Should look like this. Okay. Starting from T1 to T2. So this represents deceleration, right? Deceleration. So deceleration මෙතනදී f හරි මොකක්ද දානවා. So negative sign එහෙම දාන්න ඕනේ නැහැ. Graph එක දැක්කම අපි දන්නවා that it's a deceleration. Okay. So this is the basic graph that it looks like. Okay. Now we look at an example. Right. So this is similar to the previous example. We start with t equals 0 and you start at time t equals 0 with a velocity u, right? And it's moving with constant deceleration. So notice here that I mentioned in the same direction but with a negative sign f, right? So you start at somewhere, let's say u somewhere, and deceleration f, right? Until t1, right? So at this point it is v1. So this is f. Okay. So notice here I'm gonna use theta, okay, with respect to negative axis. Now usually if the gradient is negative, we're gonna measure the angle with respect to positive t axis. But when it comes to problems, it's easier to mention the acute angle. මේ පැත්තේ තියෙන acute angle එක mention කරන එක අපිට lazy ගණන් හදාගෙන යද්දී. Then from t equals t1 to t equals t2, it moves with negative deceleration, with deceleration f by 2. f by 2 කිව්වහම තර f ට වැඩි f by 2 අඩුයිනේ. ඒ හින්දා මෙයාගේ මේ inclination එක අඩු කරන්න ඕන. අර කලින් වගේම තමයි. Right? So like this. So let's take this to be alpha. Now in this case this to be alpha. So this should be our V2. Right. So here we have f by 2. F by 2. Sorry. Yeah. This is alpha. Now මෙහෙම ගන්න අතර අපිට හරියට මුලින් ලියන්න පුළුවන් f by 2. Right. Then what happens? From this is V2, then it moves in constant deceleration 2f. Now this is greater than f, twice as greater than that. ඒ හින්දා මෙයාට වැඩි inclination එක ගොඩාක් වැඩි කරන්න ඕනේ. හැබැයි මෙතන පේනවා මේ v equals 0 වෙනකම් විතරයි යන්නේ. 0 වෙනකම් විතරයි යන්නේ. උඹලා දන්නවා constant deceleration එක තිබ්බොත් particle එක මෙනේ move වෙලා friction එකක් නැති හින්දා deceleration වෙද්දී velocity එක decrease වෙලා 0 වෙනවා at some point. ඊට පස්සේ එතන නතර වෙන්නේ නැහැ. අනිත් පැත්තට එනවා. හරියට vertical motion එක වගේ යන්න gravity. හරිද? එතන මෙතන මම graph එක v0 වෙනකම් විතර අඳින්නේ. එහෙම mention කරලා තිබ්බ නැත්නම් graph එක කෙලිම පල්ලෙහාටම යන්න පුළුවන් 0 එකක් කපාගෙන. So the inclination should be greater than this. So let's make it abrupt. Okay. So in this case 2f. So notice here this. Let's take this to be. Now this point is t3 let's call this beta. So notice here that alpha is the least value, beta is the greatest value, and theta is big V. Okay. Right. So this is about particle moving constant deceleration. Now let's do case 5 and case 6. These will not come up in the exam, so I'm not going to do examples for that. Increasing acceleration. Acceleration is the slope of the curve. Increasing the acceleration means the acceleration also increasing, which means slope has to increase. That means it's a graph like this. So notice here the slope is this. When it moves, slope increases. Slope increases. This is increasing acceleration. Then decreasing acceleration would look like this. Remember, concave up, concave down, right? So notice here, decreasing acceleration. Acceleration decreases with time, right? But still an acceleration. It is still an acceleration. If you have an acceleration, you know that velocity will always keep on increasing. See, velocity කවදාකවත් පල්ලෙහාට ගියලා නැහැ. මෙයා එන්නේ increase වෙන එක තමයි වෙන්නේ. හැබැයි increase වෙන rate එක එන්න අඩු වෙනවා. So you can see the slope of a curve is the acceleration. Slope decreases and becomes zero somewhere. So now next we look into increasing deceleration and decreasing deceleration. So case 7 and case 8, increasing deceleration. Deceleration means slope is negative. Deceleration also increases, which means the velocity rapidly decreases. Looks like this, right? So you can say the slope increases. May slope increase now. So me angle එක බලන්න angle එක මේ n increase, right? Constant. Increasing deceleration. Then decreasing deceleration. Decrease. Say it at all times. This is a deceleration. Deceleration means velocity must decrease. A decrease in a rate එකක් එන්න වෙනස් වෙනවා. See, the slope is decreasing. Slope can angle එක decrease. Right. Now we will see the derivation of equation of motion from the VT graph. So make a good place. We start with a basic model starting at t equals 0 with velocity u and moves with acceleration, constant acceleration until the velocity reaches v at time t. So constant acceleration in the we start at t equals 0. So මෙන්න මේ හැලින් අපිට start කරන්න ඕනේ. Start කරලා ඔන්නෝ move වෙනවා. Right. So මෙන්න මේ angle එක පෙන්නන්න. Acceleration f පෙන්නන්න. මෙතන u, so it should be here v. So මෙන්න මේක තමයි අපිට වෙන්න ඕනේ. මේ line segment එක විතරයි තියෙන්නේ. This is only line segment. Right? Represent this motion. මේ සම්පූර්ණ motion එක මේ line segment එකෙන් පෙන්නනවා. This is t. Right? This is t equals 0. Okay. So let's name special points here. Let's take this O and let's take this A, B, C, and D points. Right. So you can see that you get a trapezium here. Then Abhibalan. As I mentioned here, the slope of a line segment is actually gives you the acceleration of a particle. Now let's prove this. Right. So gradient of the line AB, line segment AB, MAB, right? Gradient of line segment AB is equal to tan theta. Right? Tan theta, we make it theta. So what is tan theta? Tan theta is this difference divided by this difference. So tan theta is BC divided by AC. This is MAB. Right. Now BC is V minus U. V minus U. AC is the time up to this point. So time is actually T. හරි මේ ඔයාට පුළුවන් time එක මෙහෙම කරලා පෙන්නන්න. එහෙම නැත්නම් coordinate එකක් විදිහට time එක පෙන්නන්න පුළුවන්. Right, this is equal to T. Now M A B. So now let's rearrange this equation. You see T into this is M A B T. And now I take u over to the other side, so that would give me u plus MAB times t. Make a දැකලා පුරුදු මොකක්ද? V equals u plus AT. V equals u plus at. So when you compare these two, I will get a is equal to MAP. तर මේ graph එකට අනුව අපි acceleration එක ගන්නවා f කියලා. ඔන්න proof එක. So this is the proof. So I prove here that the slope, therefore slope represent acceleration. Slope represent acceleration. ඊළඟට අපි බලමු මේ graph දැන් අපිට vt graph එක අපිට අඳින්න පුළුවන් plot කරන්න පුළුවන් velocity එකයි time එකයි විතරයි. Right? As a graph එක බලලා is as a result of this graph we get acceleration and we also get the displacement with respect to the starting point. So starting point කිව්වහම ඔයගොල්ලෝ start කරන point එක ඉඳන් මේ point එකේ වෙන්න පුළුවන් එහෙම නැත්නම් t1 මොකක් හරි මෙතන point එකේ වෙන්න පුළුවන් time එක. ඒතර time එක ගන්න point එක ඉඳන් තමයි again time එක t1 වලදී මොකක් හරි point එකක් තියෙන point එක particle එක ඉන්නවනේ කියමු. එතන ඉඳන් measure කරන displacement තමයි අපි ගන්න. ඊළඟ අපි බලමු මෙයාගේ area එකෙන් displacement එක එනවයි කියලා මම දැන් prove කරනවා. Right. So now let's look at the area. OABD. This is a trapezium. What is the area of the trapezium? Half times this plus this. Half times AO plus BD. AO plus BD into OD. Right. So what is this? Half. Okay. AO is U, BD is V, OD is time. Have you seen this before? So you remember S equal U plus V divided by 2 times T. අතන මේ දෙක compare කරාම when you compare these two we get area OABD actually gives you S, the displacement. Right. So you can see that we can derive equations of motion, the basic equations of motion from the graph. What we derive only two equations, v equals u plus at and s equal u plus v by 2 times t. If you can remember the derivation of equation motion, first we derived these two equations and based on this we derive the next two equations. So we can do the same thing using the graph. So I will give you as an exercise, try to derive the other two equations using this graph. Okay. Right, so this is the end of all the theory part. Next we'll look into some examples. So I will start with a simple example 1 or 2, then we'll move on to advanced problem, probably that consists of two particle motions. Right, so let's start with a simple example. A car starting from rest, right? A car starting from rest, which means the initial velocity is 0. So අපි rest again පටන් අරගෙන කොයි හරි පැත්තකට move වෙනවා. Moves with constant acceleration for 10 seconds. For 10 seconds it accelerates, right? නැත්තම් move වෙන්න බෑනේ, acceleration එකක් වෙන්න ඕනේ. car එකකට 0 ඉඳන් start කරලා. Right? එක පාට එයාට v කියන acceleration එකට යන්න බෑ, අනිවාර්යෙන් බිඳුව ඉඳන් පටන් ගන්න ඕනේ. So moves with constant acceleration for 10 seconds. Right? And reaches a speed of 50 meters per second. 10 seconds වල යන දැන් acceleration එක මොකක්ද කියලා කියන්නේ නැහැ. It doesn't say anything about the acceleration. You may probably have to find the acceleration. So it only says it moves with the constant acceleration for 10 seconds and reaches a speed of 50 meters per second. මේම ගිහලා 50 meters per second එක යනවා. සාමාන්‍ය කාරයක් එහෙමනේ accelerate කරනවා. අපි හිතමු highway එක යනවා කියලා 100 miles per hour or 100 kilometers per hour වලට accelerate කරලා එතින්නම් තියාගෙන යනවා. Right? කොච්චරද reaches speed of this? Right. Then it moves with the acquired velocity. A ගත්ත velocity එකෙන් with the acquired velocity it moves with 20 seconds, right? And is brought to rest. ඊට පස්සේ දැන් කාර් එක නවත්තන්න ඕනේ. Is brought to rest in next 10 seconds. then 20 seconds move වෙලා ඊට පස්සේ next 10 seconds වලදී මෙයා brought to rest. ඒ කියන්නේ velocity එක 0 කරන්න ඕනේ. right? In next 10 seconds. draw VT diagram. අපි බලමු. starting from rest. දැන් මෙතනින් පටන් ගන්න. right? So let's call this O. So for 10 seconds යනවා acceleration එකක් එක්ක. එතකොට අපි බලමු මෙන්න මෙහෙම acceleration එකක් ගමු. 10 second නැත්නම් මම මෙතන දාන්නම් 20 second. Yeah, let's say 5 seconds instead. නැත්නම් මේක වෙනස. 5 seconds, right? So acceleration we will take an inclination, certain inclination. Let me take this because within 10 seconds it reaches 50 meters per second, so goes up. Now notice here, if they are given meters per second, so you can put the units here. Then it should be seconds. Okay. So it reaches this velocity in 10 seconds. 10 seconds, right? 10 seconds. So I can write 10 here. මේව පෙන්නනවා නම් ගොඩක් lazy. සමහරවිට මේ coordinate form එකෙන් පෙන්නන lazy. සමහරවිට මෙහෙම interval එකක් විතර පෙන්නන හරිය. So මම දීලා තියෙන interval එකක් විදිහට interval එකක් විදිහට පෙන්නන්න. So it reaches a velocity of 50 meters per second. Unit දාන්න ඕනේ නැහැ මෙතන unit එක දාලා තියෙන හින්දා. Then it moves with the acquired velocity for 20 seconds. So 20 seconds කිව්වා මෙයා වගේ double යන්න ඕනේ. මෙන්න මේ හරියට වගේ යනවා 20 seconds. So 20. Okay. Then what happens? Then it is brought to rest in next 5 seconds. Again මෙයාගෙන් භාගෙන් මෙයා ටක් ගාලා brought to rest. එතන මෙන්න මේ හරිය වගේ brought to rest. 5 seconds. Okay. බලන්න මේ angles වෙනස් නේ. මෙතන theta, මෙතන අපි ගමු beta. Let's take this is to be beta. So we don't know acceleration and deceleration. Let's say this is F1. Let's call this is F2. Right. So we have to first draw a VT diagram and find acceleration. So the car accelerates from here to here. Let's call it A, B, C, D and E. So accelerate again for the first 10 seconds the car accelerates. So acceleration, how do you obtain acceleration from VT diagrams? You obtain acceleration from VT diagrams by considering the slope, right? Or gradient. So make a gradient එක ගන්න. බලන්න මේ gradient එක ගත්තාම tan theta is equal to this distance AE මට ඒවා කියන්න ඕනේ නැහැ. මෙතන 50 වෙනවා. 50 divided by 10. So what is tan theta? Tan theta is F1. Let's see, 5 meters per second. බලන්න කොච්චර. Notice how easy this is. तर අපි maths වල කරන්නේ පුළුවන් තරම් මොකද්ද? මේක lazy කරන එක. तर equations by using equations you can get the same thing, but if you use equation, you have to come up with the correct equation and maybe solve for x and obtain the correct acceleration. तर මේ වගේ acceleration ටික හරියට දැනගන්න ඕනේ. तर v equals u plus at දාලා මේක ගන්නත් පුළුවන්. ප්‍රශ්නයක් නැහැ. හැබැයි මෙතනදී බලන්න simple එකක් ගත්තේ 50 divided by 10 directly මම ගත්තා. 50 divided by 10. Right. Next, retardation. Retardation means deceleration. Retardation, where does retardation occurs? This is uniform velocity. This is uniform deceleration or retardation. Retardation when the method F2 done it again we have to consider the slope. Consider slope. Let's call it tan beta. Tan beta is dattahama මේ triangle එක ගන්න. මේ triangle එක right angle triangle. This is a right angle triangle. Tan theta. Right, see, these are all right angle triangles. May length එක 50. This is 5. 10 meters per second. Right, 10 meters per second. So F2 retardation is 10 meters per second retardation. Okay, 10 meters per second. Then find the total distance. This is where the magic happens, right? In a VT diagram, you can directly obtain the total distance by considering the graph. But if you use equations of motion, you know here the acceleration is not constant. From here to here it is F1, here no acceleration, here you have retardation, which means you cannot write equations for the complete motion. සම්පූර්ණ motion එකට එකපාර equations දාන්න බෑ. කඩ equations දාන්න. දාලා ඉවරලා ඒ displacement එක ආයි එකතු කරන්න ඕනේ. You have to sum them up, right? But you can see the displacement of this, the total distance it has traveled from the starting point O can be obtained by considering the area under the curve, right? Area under the curve. So distance again, distance is actually area OABC trapezium, right? කෙලින් බලන්න half බලන්න කොච්චර ලේසිද half times trapezium එකේ area ගත්තාම this plus this. So what is this? This is 20. What about this length? This length is 20 plus 10 plus 5. So that is 35. Right? Into this height. මේක තමයි trapezium. Height එක 50. See? Right. So yeah, you can see. So the distance is 55 into 25. So calculate the amount of distance and write it down. ඉතින් මෙච්චරයි තියෙන්නේ. මහලු දෙයක් නෑ. හැබැයි two particles ආවම මේක පොඩ්ඩක් complicated when, right? So this is a simple problem. So we start with the simple problem. Next we'll look into two particle problem. Right. So this is a two particle problem. So you can see we have a cyclist and a car. A cyclist P moving at constant speed of 20 meters per second passes a car Q moving with speed 10 meters per second. So both car and the cyclist are moving with constant speed. Cyclist moving with constant speed 20 meters per second and car Q is moving with 10 meters per second. දැන් ඔයගොල්ලෝ දන්නවනේ සයිකල් එකක් මෙහෙම කාර් එකක් පාස් කරපු ගමන් වේගෙන් කාර් එක මොකද කරන්නේ? කාර් එකට නලියනවා ඉන්න බෑ ඒ ස්පීඩ් එකෙන් ටක් ගාලා එයා ඇක්සලරේට් කරනවා වෙලොසිටි එක ඉන්ක්‍රීස් කරන්න. හරි. දැන් මෙයාව 20 meters per second පාස් කරපු ගමන් මෙයා යනවා 10 වලින්. මෙයා යනවා 20 වලින්. හරි. 20 වලින් යනවායි කියලා කියන්නේ අරයා කාර් එක පාස් කරපු ගමන් මෙයා ඉස්සරහින් ඉන්නේ. Cyclist is ahead of the car, right? So cyclist move වෙනවා 20 meters per second. So within a second තප්පරයක් ගත්තොත් එහෙම cyclist මෙයාව පාස් කරපු time එකේ ඉඳන් within a second cyclist 20 meters ගිහිල්ලා තියෙනවා. කාර් එක 10 meters ගිහිල්ලා තියෙනවා. ඒතර එතන gap එකක් තියෙනවා. දැන් කාර් එක මොකද කරන්නේ? It accelerates so that its velocity increases. අනිවාර්යෙන් මෙහෙම chase එකකදී ඉස්සරහ එක්කෙනාව පාස් කරන්න නම් මෙයාගේ velocity එක වැඩි වෙන්න ඕනේ. දැන් මෙහෙම යනවනේ. ඉස්සරහ එක්කෙනාව පාස් කරන්න නම් පිටිපස්සේ එක්කෙනා velocity එක ඉස්සරහ එක්කෙනාට වැඩිය velocity එක increase කරන්න ඕනේ. දැන් increase කරන්න නම් you have to accelerate. එහෙනම් accelerator එක push කරනවා. හරි. At that instance the car increases speed with constant acceleration. Constant acceleration problem විතර අපිට handle කරන්න පුළුවන්. Until it catches the cyclist at B. Right. තර මේකයි වෙන්නේ. At A and at B කියලා තියෙනවා. මේ point එක A කියන point එකේදී at point A, so let me draw a picture, real picture. Right, so this is what happens. At time t equals 0, car එක දැන් මේ snapshot එකක් ගන්නවා කියලා හිතන්නකෝ. A කියන location එකේ ඉන්නවා. stay still නෙමෙයි. මේක දෙන්නම යද්දි එකපාර snapshot එකක් ගන්නවා. A කියන point එකේ ඉන්නේ. දෙන්නම. හරි. මේ වෙලාව තමයි passing එක වෙන්නේ. Right. So because this is moving at 20 meters per second, this is moving at 10 meters per second. So what happens? This goes beyond, I mean this passes the car Q, pass kar at that instance මෙයා accelerate කරනවා. එතකොට acceleration එක correspond වෙන්නේ Q කියන particle එකට විතරයි. ඔව් car එකට. එතකොට මෙයා accelerate වෙගෙන යනවා. අනිවාර්යෙන් මෙයාව chase කරන්න නම්, ඒ කියන්නේ මෙයාව අල්ලන්න නම්, overtake කරන්න නම් velocity එක අනිවාර්යෙන් වැඩි වෙන්න ඕනේ 20 meters per second වලට වැඩි. දැන් මේ accelerate කරගෙනම යනවා. පුළුවන් තරම් accelerate කරගෙන යනවා. Until it catches the cyclist at B. එහෙනම් දැන් මෙයා කොහොමද accelerate කරන් ගිහලා මේම ඔන්න මෙයාව overtake කරන point එක snapshot එකක් ගන්න එකෙන් ඒ location එක B වල. එතකොට time එක elapse වෙලා තියෙනවා T, distance එක S. දැන් මෙතන distance එක දීලා නැහැ. AB distance එක is not given and the time is not given. Acceleration is also not given. So what are given? Starting velocity of the cyclist is given. Starting velocity of Q is also given. ඔච්චරයි දීලා තියෙන්නේ. Right. So what they asking is to find the velocity of Q, the velocity of the car at B. මේ වෙලාවේදී velocity එක. Right. මුලින්ම we have draw a VT diagram. तर මේක ටිකක් okay, if you use equation motion it will take some time to get the answer. Then finally at the second point, given the chase is 10 seconds, given the chase මේ chase එක 10 seconds වලින් ඒ කියන්නේ time එක within 10 seconds මේ chase එක වෙනවයි කියලා අරගෙන find the distance AB distance එකයි acceleration එක හොයන්න කියලා. තර මේ velocity එක හොයද්දී ඔයගොල්ලන්ට මේ 10 second chase එක ගැන මේ පාවිච්චි කරන්න බෑ. So we'll do the VT diagram now. Right. Right. So let's draw the curve for cyclist. Cyclist P is moving with 20 meters per second. So මෙන්න මේ හරියෙන් 20 meters per second වලින් හරි. එයා දිගටම moving with constant velocity. This is the path of this is the curve of P. Then passes a car Q moving with constant speed 10 meters per second. May 20, this is 20, so let's take in meters per second. 10 meters per second at the chase may t equals 0 වලදී 10 meters per second. So මෙයා pass කරන that ගාම මොකද මෙයා increase කරන its velocity with constant acceleration. तर මේ constant acceleration එකේ මෙයා යනවා. අපි හිතමු at time t මොකද අපේ distance මේකේ අඳින්න බෑනේ. distance plot කරන්න බෑ. distance is obtained as a result of this diagram. So this is for Q. This is for Q. And let's say at time t we made the chase, right? So this overtake. So let's take this angle theta and acceleration is taken to be F. Let's use another color. මේ වෙන color එකක් ගන්නම්. Right. This is for Q. Then කොහොමද ගන්න? Now we should find the velocity at this point. What is the velocity at this point? Right. So what is the first thing we are asked to find? We are asked to determine this velocity. Velocity of the car at the instance the car overtakes cyclist. We are not given acceleration. We are not given time. Right. එතකොට ඔයගොල්ලෝ දන්නවා x මේ slope එකෙන් acceleration එක පෙන්නනවා. Acceleration is represented by the slope. So මේ slope එක ගත්තම f ගත්තහම මට f is equal v minus u over t. මෙහෙම ගන්න පුළුවන් f is equal to the gradient. Gradient is this amount divided by t. Right. දැන් ප්‍රශ්න තියෙන්නේ මොකද්ද? අපි v දන්නෙත් නැහැ, t දන්නෙත් නැහැ. We don't know v, we don't know t. So we cannot use neither we know f. We don't know f, t, u. මේ තුනම දන්නේ නැති හින්දා මේක පාවිච්චි කරලා හරියන්නේ නැහැ slope එක. Now we know one thing. AB distance, right? AB distance is the same for both car and cyclist because at the moment the cyclist passes the car accelerates until it catches the cyclist again. එතකොට A වලින් නම් B ට යද්දී cyclist ගිය දුර cyclist ගේ displacement එක must be equal to the displacement of the car. तर අපි ඊළඟට area දෙක equal කරලා බලනවා මොකද වෙන්නේ කියලා. Right. So now let's equate the areas and get the answer. since the distance travelled by the cyclist is equal to the distance travelled by the car, so we're going to measure the distance starting from t equals 0. Again, a point එකේ ඉඳන් අපි යනවා. මෙතන මම AB වෙන මම ගන්නම් P A B C D E F and G because A and B has been already used, right? එතකොට distance travelled by cyclist के distance එක ඉන්නේ area under this curve. This is a square, right? So that is area of OCDE must be equal to area of the car. Car eකට area of this OFGE. මෙන්න මේ trapezium එකේ OFGE. මොකද this belongs to this graph belongs to Q car. तर මේ graph එකේ area එක. දැන් මෙයාගෙන හිතන්න එපා. මේ area එක පේනවා displacement එක car එකේ. Right. Area OCDE. That is, let's take this to be our T. तर mark වෙලාම තියෙන්නේ හිමයි. එතකොට this is 20 into T must be equal to, this is a trapezium, half into 10 plus V. 10 plus V into T. And that can be ready. Right? So S equal U plus V divided by 2 times T. Okay, we don't have the acceleration. Right? We don't have the acceleration. But we have time. So when we equate the displacement, this T cancels out. බලන්න වෙන දේ T to T කැපෙනවා. So 40 equals 10 plus V. So V is 30 meters per second. V is therefore 30 meters per second. Right. Next they ask, imagine T is equal to 10. Take T to be 10 and find acceleration and the displacement, right? The length between A and B. So let's take T 10 seconds. Then in that case, then අපි V කියන එක දන්නවා, T දන්නවා. तर මේ velocity difference එක we know, the time length we know, so we can take tan theta equals V minus 10 divided by T, right? So tan theta is actually F, the acceleration. B we just measured 30 divided by 10. This 20 divided by 10 is 2 meters per second. Then displacement. For the displacement, you can take any of the curve. The බලන්න මෙයා simple නේ. මෙයා simple. This is a rectangle. So a distance AB distance must be the area of OCDE area. Right. So OCD is 20 into time, which is 20 into 10. So basically 200 meters. Okay. So you can see how easy this is to use VT diagrams. VT diagrams පාවිච්චි කරන්නේ නැතුව මේක equation එකනොත් ඔයගොල්ලෝ කරලා බලන්න ලේසිද නැද්ද කියලා. Right. Right. So we did two problems, two examples. One is a basic one that requires motion of two particles, car and a cyclist. So if I have time until Tuesday, I will upload more advanced examples. But until then, this is enough for you guys, so that we can start. Right? When you come on Tuesday to the class, we will try to draw VT diagrams. So I'm thinking of spending the first 2 hours or the whole 4 hours on drawing VT diagrams, right, or VT graphs, right? So then in the next day we will see how to use VT diagrams to solve problems. So VT diagram එක ඇඳගන්න බැරි වුණොත් එතනින් එහාට කතා කරලා තේරුමක් නැහැ. එහෙනම් VT diagram එක ඇඳගන්න එකයි මේකේ වැදගත්ම දේ. අනිවාර්යෙන් ඒක අඳිනවට ලකුණු හම්බ වෙනවා. So based on that you get the results. ඒක පාවිච්චි කරලා results ගන්න එක ඊළඟ part එක. අරක foundation එක VT diagram එක වැරදුනොත් ඔක්කොම වැරදි. එහෙනම් drawing VT diagrams is very important, so we will focus on that on this Tuesday. Right, thank you.